All right, let's get up our picture of the Earth. The Earth is pretty awesome. I'm a geologist, so I get pretty psyched about this. But the Earth is great. It's powerful, it's dynamic, it's constantly changing. It's a pretty exciting place to live. But I want to share with you guys today my perspective as a geologist in how understanding Earth's past can help inform and guide decisions that we make today about how to sustainably live on Earth's surface. So there's a lot of exciting things that go on the surface of the Earth. If we zoom in here a little bit, I want to talk to you guys a little bit about one of the things that happens is material gets shuffled around Earth's surface all the time. And one of the big things that happens is material from high mountains gets eroded and transported and deposited in the sea. And this process is ongoing all the time, and it has huge effects on how the landscape works. So this example here in South India, we have some of the biggest mountains in the world. And you can see in this satellite photo, rivers transporting material from those mountains out to the sea. You can think of these rivers like bulldozers. They're basically taking these mountains and pushing them down towards the sea. I'll give you guys an example here, right? So we zoom in a little bit. I want to talk to you guys specifically about a river. You can see these beautiful patterns that the rivers make as they're pushing material down to the sea. But these patterns aren't static. These rivers are wiggling and jumping around quite a bit, and it can have big impacts on our lives. So an example of this is the Kosi River. So the Kosi River has this nice C-shaped pathway, and it exits the big mountains of Nepal, carrying with it a ton of material, a lot of sediment that's being eroded from the high mountains, and it spreads out across India and moves this material. So we're going to zoom in to this area, and I'm going to tell you a little bit about what happened with the Kosi. It's an example of how dynamic these systems can be. So this is a satellite image from August of 2008. And this satellite image is colored so that vegetation or plants show up as green and water shows up as blue. So here again, you can see that C-shaped pathway that this river takes as it exits Nepal. And now this is monsoon season. August is monsoon season in this region of the world. And anyone that lives near a river is no stranger to flooding and the hazards and inconveniences at minimum that are associated with that. But something interesting happened in 2008, and this river moved in a way that's very different. It flooded in a way that's very different than it normally does. So the Kosi River is flowing down here, but sometimes as these rivers are bulldozing sediment, they kind of get clogged, and these clogs can actually cause the rivers to shift their course dramatically. So this satellite image is from just 2 weeks later. Here's the previous pathway, that C-shaped pathway, and you notice it's not blue anymore. But now what we have is this blue pathway that cuts down the middle of the field of view here. What happened is the Kosi River jumped its banks. And for reference, this scale bar here is 40 miles. This river moved over 30 miles very abruptly. So this river got clogged and it jumped its banks. Here's an image from about a week later, and you can see these are the previous pathways. And you can see this process of river jumping continues as this river moves farther away from its major course. So you can imagine in landscapes like this, where rivers move around frequently, it's really important to understand when, where, and how they're going to jump. But these kinds of processes also happen a lot closer to home as well. So in the United States, we have the Mississippi River that drains most of the continental US. It pushes material from the Rocky Mountains and from the Great Plains. It drains it and moves it all the way across America and dumps it out in the Gulf of Mexico. So this is the course of the Mississippi that we're familiar with today, but it didn't always flow in this direction. If we use the geologic record, we can reconstruct where it went in the past. So for example, this red area here is where we know the Mississippi River flowed and deposited material about 4,600 years ago. Then about 3,500 years ago, it moved to follow the course outlined here in orange. And it kept moving, and it keeps moving. So here's about 2,000 years ago, 1,000 years ago, 700 years ago, and it was only as recently as 500 years ago that it occupied the pathway that we're familiar with today. So these processes are really important, and especially here, this delta area where these river jumping events in the Mississippi are building land at the interface of the land and the sea. This is really valuable real estate, and there's some of the most deltas like this are some of the most densely populated areas on our planet. So understanding the dynamics of these landscapes, how they formed and how they will continue to change in the future is really important for the people that live there. So rivers also wiggle. These are sort of bigger jumps that we've been talking about. I want to show you guys some river wiggles here. So we're going to fly down to the Amazon River Basin. And here again, we have a big river system that is draining and moving and plowing material from the Andes Mountains, transporting it across South America and dumping it out into the Atlantic Ocean. So if we zoom in here, you guys can see these nice, curvy river pathways, right? Again, they're really beautiful, but again, they're not static. These rivers wiggle around. We can use satellite imagery over the last 30 or so years to actually monitor how these change. So take a minute and just watch any bend or curve in this river, and you'll see it doesn't stay in the same place for very long. It changes and evolves and warps its pattern. If you look in this area in particular, I want you guys to notice there's a sort of a loop in the river that gets completely cut off. It's almost like a whip cracking and snaps off the pathway of the river at a certain spot. So just for reference again, so in this location, that river changed its course over 4 miles over the course of a season or two. So the landscapes that we live in on Earth, as this material is being eroded from the mountains and transported to the sea, are wiggling around all the time, they're changing all the time, and we need to be able to understand these processes so we can manage and live sustainably on these landscapes. But it's hard to do if the only information we have is what's going on today at Earth's surface, right? We don't have a lot of observations. We only have 30 years worth of satellite photos, for example. We need more observations to understand these processes more. And additionally, we need to know how these landscapes are going to respond to changing climate and to changing land use as we continue to occupy and modify Earth's surface. So this is where the rocks come in. So as rivers flow, as they're bulldozing material from the mountains to the sea, sometimes bits of sand and clay and rock get stuck in the ground. And that stuff that gets stuck in the ground gets buried, and through time, we get big, thick accumulations of sediments that eventually turn into rocks. What this means is that we can go to places like this where we see big, thick stacks of sedimentary rocks and go back in time and see what the landscapes look like in the past. We can do this to help reconstruct and understand how Earth landscapes evolve. This is pretty convenient too because the Earth has had sort of an epic history, right? So this video here is a reconstruction of paleogeography for just the first 600 million years of Earth's history. So just a little bit of time here. So as the plates move around, we know climate has changed, sea level has changed. We have a lot of different types of landscapes and different types of environments that we can go back. If we have a time machine, we can go back and look at. And we do indeed have a time machine because we can look at the rocks that were deposited at these times. So I'm going to give you an example of this. I'm going to take you to a special time in Earth's past. About 55 million years ago, there was a really abrupt warming event. And what happened was a whole bunch of carbon dioxide was released into Earth's atmosphere, and it caused a rapid and pretty extreme global warming event. And when I say warm, I mean pretty warm, that there were things like crocodiles and palm trees as far north as Canada and as far south as Patagonia. So this is a pretty warm time, and it happened really abruptly. So what we can do is we can go back and find rocks that were deposited at this time and reconstruct how the landscape changed in response to this warming event. So here, yay, rocks. So here's a pile of rocks. This yellow blob here, this is actually a fossil river. So just like this cartoon I showed, these are deposits that were laid down 55 million years ago. As geologists, we can go and look at these up close and reconstruct the landscape. So here's another example. The yellow blob here is a fossil river. Here's another one above it. We can go and look in detail and make measurements and observations, and we can measure features. For example, the features I just highlighted there tell us that this particular river was probably about 3 feet deep. You could wade across this cute little stream if you were walking around 55 million years ago. The reddish stuff that's above and below those channels, those are ancient soil deposits. So we can look at those to tell us what lived and grew on the landscape and to understand how these rivers were interacting with their floodplains. So we can look in detail and we can reconstruct with some specificity how these rivers flowed and what the landscapes look like. So when we do this for this particular place at this time, if we look what happened before this abrupt warming event, the rivers kind of carved their way down from the mountains to the sea. And they did so, they looked maybe similar to what I showed you in the Amazon River Basin. But right at the onset of this climate change event, the rivers changed dramatically. All of a sudden, they got much broader, and they started to slide back and forth across the landscape more readily. Eventually, the rivers reverted back to a state that was more similar to what they would have looked like before this climate event, but it took a long, long time. So we can go back in Earth's time and do these kinds of reconstructions and understand how Earth's landscape has changed in response to a climate event like this or a land use event. So some of the ways that rivers change, or the reasons that rivers change their pattern and their movements, is because of things like with extra water falling on the land surface when climate is hotter, we can move more sediment and erode more sediment, and that changes how rivers behave. So ultimately, as long as Earth's surface is our home, we need to carefully manage the resources and risks associated with living in dynamic environments. And I think the only way we can really do that sustainably is if we include information about how landscapes evolved and behaved in Earth's past. Thank you.